And then we're going to see. So we're going to do, write your sum out, n minus 1. Put those in parentheses. N minus 1 plus n minus 2 plus dot 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 plus 2 plus 1 plus 0. And then minus n. Okay. So what does this first sum equal?
Well, it's n. So there'd be n. There's n terms here,
Yeah.
and then you can write this whole thing backward, and you get n minus 1 times n, and the sum, there'll be double it, so the sum is n minus 1 times n over 2
Okay.
minus n.
Minus n. All right. So let's see if we could simplify this if we wanted to, but we actually don't really need to. So what about when n equals 3? What do we get for this?
So we get 2 times 3 over 2. That's just 3 minus 3, 0.
Okay, good. What about for 4?
You get 3 times 4 over 2, which is 6 minus 4, which is 2.
All right, and then for 5?
4 times 5 over 2, it's 10 minus 5 is 5.
Okay, interesting.
It seems to work.
All right, so if we simplify this, we just get a common denominator. 2, right? So this is n squared minus n. That's this part, right?
Mm-hmm.
Minus 2n over 2, right?
Yeah.
So we get n squared minus 3n over 2. Or n times n minus 3. Oops. So we could think of we could interpret this as a counting thing as well. There were n times n minus 3 things, and we double counted. Sorry, I was trying to get pen down and did a pretty bad job. Alright, so do you see n copies of n minus 3 things in the pentagon when we're trying to count the diagonals?
Well, yeah, I see the 5 copies because there's this here, these 2 lines coming from every vertex.
Yeah, so but we're ignoring the sides, we're just counting the diagonals, and there's 2 copies coming from every vertex. And how many vertices are there?
5.
And how many times do you count each diagonal in that set?
Twice.
Twice.
Because they go to the diagonals.
Yeah, so your way of counting it was actually really good. You said, I'm going to count all the lines emanating,
And then subtract away the sides.
and then subtract away the sides, and you avoided double counting by saying n minus 1, n minus 2, n minus 3. So that's fine. But there's another way, and the algebra simplifies to n times n minus 3 over 2, and so you get this. Anyway, that was good work. That was good work.